All right. Good morning, everyone. I'm recording. This is Jeff Scott. Welcome to day 22 of our summer 2023 online AWD C# programming class, AWD1100 at Rankin Technical College. Again, today is day 22. It is Thursday, the 22nd of June. And we are going to be switching a lot of gears today because we're going to be going into chapter 12, which is on object-oriented programming. This chapter is going to be a little bit different. I'm not even sure how much we'll get into chapter 12 today, but I want to talk about some concepts first. All right, and we will do that in just a second. But before we do, I want to mention a few things. First, as it says right there, your hands-on test was due yesterday. All right, now at least one person has contacted me and said they had problems saving their work. I got back to them, but just let me tell you, and I again, if I'm supposed to apologize for this, I'll apologize for this. All right, literally, I fell asleep in my living room yesterday at about 8 o'clock, and my wife came in and woke me up around 10 and said, "Hey, go to bed." So I did. So I didn't really look at my phone after 8 o'clock last night. So if you tried to contact me after 8 last night, I got back to you this morning. All right. So again, hands-on test hot 4 was due yesterday. All right. Your homework, written tests, etc., all that work was also due yesterday. All right. Now, I'm going to grade this weekend. I will probably start my grading tomorrow. And if it turns out, as we're getting into things that are more and more, I'm not going to say hard, but let's say complex, if it turns out that people did poorly or some people did poorly on that test yesterday, what I may end up doing is doing the test for you in class on Monday. I don't know. We'll see, because I don't know. I haven't graded, I haven't looked at any of them yet. All right. So with that said, the other thing I want to mention that is related to this, because I got an email this morning where somebody said, "Hey, I'm behind on my work. Can I turn in late work?" The answer is yes. And as it says on the screen right here, the amount that I take off will depend on both how late you turn work in and the quality of your work. If something was due yesterday and you turn it in today, you'll get hit either with no penalty or with just a slight penalty. On the other hand, if you turn it in a week from today, yeah, the penalty for being that late would be more substantial. All right. I've got certain people in here who some tend to do the written tests, but then turn in their homework and labs late, and other people who turn and homework done on time and they turn their written tests in late. So if you've lost some points on there, if you have turned in something late, even if it was of high quality, you probably lost at least some points. Now, I try to be as fair as I can with this stuff. You had 5 programs that you were supposed to be turning in by yesterday for your homework and labs. All right. And of those 5 programs, 2 of them we did as a class. So you already had those. All right. Okay. So with that said, try to think of the best way to do this. And what we're doing right now, just so you know, close a few of these things up here. All right. But what we're doing is we have now gone through all of section 1 and all of section 2. You're probably going to find that what we go through in section 3 will be the hardest stuff we've done thus far. And it's because in some ways, we're going to be doing things a lot differently. All right. But before you say, well, what does that mean? I'm going to show you. But what I want to show you in a couple minutes too is you now get the basics. All right. You've been introduced to basic programming concepts. You understand variables and constants. You understand the different data types that we have. Mainly, we've used string and we've used bool, and we've used decimal or double, and we've used int. But you've got an understanding of those. You understand conditional statements, where we have come in and we have used if else, if else, if else, switch, etc. You understand loops. We've gone through for loops, even the for each loop. We've gone through while loops, and we've gone through do while loops. All right. We've also gone over functions, modularity, and why you write functions. All right. We've gone through exception. So when you look through half this book, we've done a lot of stuff already. I didn't even mention we've gone through arrays and collections. All right. You recently just learned working with dates and strings, adding some additional controls like radio buttons, drop down lists or combo boxes, list boxes, check boxes, group boxes. We've gone through a lot already. I mean, when you look at this, we've gone through about 370 pages in the book. And what that means to me, at least, is we're a good halfway through. All right. Now we're going to go into the world of object-oriented programming. And what I want you to understand as we start on this is you've already been using a lot of this stuff. You've already been using classes. You've already been using objects. You just don't realize that you have. All right. So I'm going to go through some terminology. I'm going to go through a couple of articles. And believe me, when I show you this stuff, you might look at the titles and say, well, I'm sorry, this is very insulting. I don't mean to insult you at all. All right. But I'm trying to familiarize you with some object-oriented concepts. All right. And if you say, I don't know what that is, again, that's the subject of today's lecture. But C# is an object-oriented programming language. Everything you do in C#, you are working with classes and objects, even the stuff we've already done. I'm going to show that to you and hopefully prove that to you in just a little bit. Now, for those of you who were in the AWD1000 class, the Web Development Technologies class last spring, towards the middle on in that class, we went over a language called JavaScript. Now, I like to call JavaScript, rather than an object-oriented programming language, I like to call JavaScript an object-based programming language. So what's the difference between object-oriented and object-based? Well, with a language like Java being object-based, it means you've got full object-oriented capabilities, but you never have to use them if you don't want to. You can become quite a proficient JavaScript programmer and do very little work ever with object-oriented programming. In fact, we didn't discuss in that class object-oriented programming until very late in the semester. Just to show you, if I go back here, and this is the book that we used for the JavaScript class, but I just want to show you this. And that is, if I go to this book, I haven't opened this up in a while, no idea what page. Oh, good. All right. We go through most of the book. All right. But when you go look, it's not really until about chapter 14, how to work with browser objects. So it's 430 pages in to about a 680-page book before we even talk about that. In fact, really, it's chapter 16, how to work with objects. So it's 500 pages in to a book that's about 680 pages. All right. Now, I'm going to introduce you right now to some terminology. I don't expect you to remember it, but I just want you to hear it. I want to explain some of the core concepts. I also want you to know, now in the program that you're in, the AWD or the Application and Website Development Program, the languages that you learn in here are basically JavaScript and C#. JavaScript, as I already mentioned, is an object-based programming language, which means you've got object-oriented capabilities, but you never have to use them if you don't want to. C# is an object-oriented, not an object-based, like JavaScript, an object-oriented programming language. That means you use object-oriented programming features, whether you realize it or not. All right. Now, Java, the Java programming language, is also object-oriented. In fact, there's a lot of similarity between C# and Java. I'm going to show you that a little bit later today. All right. Python, I look at Python as being more object-based, but you can use object orientation in there also. We don't have Python classes here, but just to mention another language to you. All right. So we're going to start talking now about some of the fundamental concepts of object-oriented programming. All right, you're going to hear some words that you're going to end up hearing over and over and over again in the next few weeks. All right, so the first article that I found here, and I just found this morning, literally, it's called How to Explain Object-Oriented Programming to Kids. And again, this is not meant to insult you, but I'm trying to start, I told you much earlier in the semester when we talked a little bit about the crawl, walk, run mentality. Or, I think I might have even given you the example that when my kids, who are now in their 20s and 30s, but when my kids started to learn to swim, they didn't jump off the diving board the first day of class. They went in the kiddie pool. From there, once they got comfortable in being in there, they went into the regular pool, but they went into the shade, going deeper into the diving board. Well, that's kind of what I'm doing here. All right. And what I like about these two articles I'm going to show you is at least some of the stuff, some of the concepts that they will talk about in here. They don't even talk about programming. They talk about something and try to keep it simple. All right. Okay. Now, it says here the whole paradigm of object-oriented programming is a concept, the concept of objects. You may or may not have heard of the word paradigm before. And basically, paradigm involves a shift in thinking. All right, so we're going to do a little bit of a shift in thinking of some of the work we've done earlier. All right, we're going to just do some stuff in a different way. All right. I got asked ago, somebody asked me, they said, can you give me a definition of object-oriented programming in one sentence? And I actually thought about it for a while. All right. And I thought, how the heck would I even answer that question? Okay. But I came up with this. Now, this is a very generic definition that I'm about to give you. And the reason I'm telling it to you like that is what I mean is, all right, it doesn't apply 100% of the time. Programming, it's also known as, it's the use of public methods to modify private data. That's what I came up with. And that is not, in fact, that is an imperfect definition. Why is that imperfect? Because not every method in an object-oriented programming is public. You can have private methods. There's even a few other kinds that we haven't talked about yet that we will talk about. Not all data in an object-oriented programming has to be private. You can use public data. In fact, you might even see some of that today. But In a nutshell, in most object-oriented programs, you public methods that you use to modify private data. Again, like I said, that is a very imperfect definition. All right. So let's jump into these articles here. It says object-oriented programming is one of the most complex parts of programming to learn and teach. If it's so difficult to learn and teach, how do you explain it to a kid? And what they say is you want to put it in a way that they'll understand it. All right. So you want the definitions that you use to be simple. You want the examples that you use to be simple. So in these two articles that I'm about to show you for the next 10 minutes or so, all right, we're not even really going to talk about a computer and how you would do things using a computer. We're going to talk about real life type of things. All right. Now, I gave you my definition, and here's the definition that's in this article. It says object-oriented programming is based on the concept of objects. Okay. In object-oriented programming, data structures, or as they're known, objects, are defined. Each object can have its own properties or its own attributes. Each object can also contain its own procedures or methods. Now, you might look at that and say, you've already lost me. Okay, well then let's look at it this way. All right, I gave you this definition already, but let's sit there and say that we wanted to make something, what we'll call it here a class, and we want to make a class called person. Well, what do all persons or all people have in common? As examples, they all have things like an eye color, a hair color. Now, if you have as little hair as I have left, but you get the idea. A height, a weight, and for example, a gender. All right. Now, everything I've shown you in here, these things here would be strings. So would that. And these would probably be integers. But we could have things, you know, for instance, I could put another thing in here and I could call it is married, which would be a Boolean. Okay. So why am I showing you this stuff? Well, what I want you to understand here is if I make a person class, that says that anytime I make a person, they'll all have these properties, these attributes that you see right here. So each person will have their own eye color, their own hair color, their own height, their own weight, their own gender, and their own marital status. They'll all have those. But if I bring in a group of 10 people, there's a pretty good chance that not all of them will have blue eyes, for example. Not all of them will have brown hair. Not all of them will be 6 feet tall. Not all of them will weigh 175 pounds. Not all of them will be male or all female. Not all of them will be married. All right. So what happens when you do something like this and you create what's called a class? A class, I've always known called a class is basically a blueprint. Now, Gudmus did, so Mr. G calls a class a cookie cutter. They both, believe it or not, pretty much mean the same thing. So imagine, if you would, wherever you live, let's just imagine you look out your window and you can look across the street, and across the street from you is this huge field. All right. And it's been out there as long as you've been in your house. All right. And you look out there one morning and you notice that there are a bunch of trucks in that field and they're excavating and they're doing different stuff. And you find out later that somebody has bought that big field of land and they're going to build a subdivision in it. All right. And what they decide to do is when they get all done, there's enough room for 100 houses in that subdivision. All right. So they bring in an architect, and the architect comes up with 5 different house plans. We'll just call them House Plan 1, House Plan 2, House Plan 3, House Plan 4, and House Plan 5. Maybe with some of the house plans, maybe. All right. So why am I telling you this? Because each one of those house plans becomes a blueprint for what you want the house to look like. Now, each one of those, so if you imagine, that we made 20 house plan ones, 20 house plan twos, 20 house plan threes, 20 house plan fours, and 20 house plan fives. All right. And maybe we set it up in 20 different rows or something like that, where we had house plan one, then a plan two, then a plan three, then a plan four, then a plan five. Then in the next row, we did it again and again and again. Well, for example, these house plan ones, who's to say they all have to have the same exterior color? They could have a different color. They could have a different type of front door. Maybe some of them are painted and some of them are sided. All right. Maybe some of them have a fireplace. Some of them don't have a fireplace. All right. So what I'm trying to tell you here is those house plans would be what we'd use for a class. They'd be blueprints. Or again, as Mr. G calls them, they would be the cookie cutters. Each house that you create, so each house would be an object. So an object is what's referred of a class. In fact, the act of creating objects from classes is called instantiation. And again, I don't expect you to remember the word. I'm just hoping that as we go through this, it makes at least a little bit of sense to all of you. That's my hope. All right. So going back then to this example, they're saying here, why would you even want to do this? Why would you even want to create objects based off of classes? And they give you a little bulletized list here with some of the benefits. You end up with programs that are faster and easier to execute. They allow you to clearly structure your program. Your code is now easier to modify, debug, and maintain. And really, the last one that's on there is the big one. You make it easier to reuse code. All right. Anytime you can talk about code reuse, it's going to cut down on development time. All right. So object-oriented programming languages are diverse, but the most popular ones are class-based languages where objects are instances of classes. Well, Java, C++, C Sharp, Python, and JavaScript are examples of some of these. It says the simplest way to explain object-oriented programming to a kid, now I just used for you guys, I just used a house. First a person, then a house. And they say something like a car. And they mention a car has a model name, a color, a year it was manufactured, an engine size, etc. So we could create a car object, and we actually might look at something like that later. All right. So in that case, the name, the color, the engine size, and the year would be referred to as attributes. All right. So as they mentioned here, for every new car, you could use a car object. For instance, as it says, you could have a 2019 blue BMW, a 2017 red Audi. All right. Now, the 2019 blue BMW would basically have the same, probably the same name, the same engine size, and the same year as other 2019 BMWs. But you probably could get a white BMW from 2019, maybe a black colored one or a gray or whatever. Same thing with the Audis. In each instance, it says there we could reuse the code for the original car that we built for the other ones. All right. Now, what's mentioned next here, and they're going to go into it right away, are what are referred to typically as the four pillars. All right. You know what pillars are, like to help support a house. But the four pillars of object oriented programming, which we're going to talk about right now, are known as encapsulation, abstraction, inheritance, and polymorphism. All right. So let's look at each one of these four. It says the principle of encapsulation entails that all properties and methods of an object are kept private and safe from interference of other objects. Okay. I'm going to demonstrate that in just a few minutes. In each object, we can have both private and public variables, private and public methods. Private variables and private methods are private to the object. They can't be used by any other object. Public things can be used by other objects. When you have object-oriented programming and you start to create objects, the idea is typically in some form or another, these objects have the ability to communicate with one another. We talked about a person object before, and if I make 10 of those person objects, they should be able to communicate with one another. All right. Now, they're going to go down a little different road here because the author says here to they can't be changed, all right, by other objects. Okay. Now, says we also could have a public method called start. All right. Why public? Well, you could have another object, like a person object, be able to start a car. So they'd be able to call the start method. Now, let me give you one more example of that. Okay. And it may or may not seem like it's what we're talking about, but it's going to be encapsulation and what we'll talk about next, which is abstraction. All right. I've used this example before. So if I come in here and I go and bring in calculator, all right, and I type in a number, let's say 367, and I click this. I don't know which one it is. I think, no, it's not that one. So I always forget. There used to be a better square root key in here, but if I type in 367 and click that button, that says that the square root of 367 is 19.157.244.060.66802. All right. Which means, and you know this already, if I grab that number and I copy it to the clipboard and I multiply the number that we have by that number, look what I get. All right. Why am I even showing you this? Well, what this does, whether you realize it or not, is the logic that was put into this calculator. All right. The logic that allows me to put in a number and then click the square root key has been encapsulated. What that means is the logic has been put inside of a calculator object. And all I can see is this public stuff here, which is referred to typically as an interface. The actual implementation, which is what happens when I click that button, the implementation is private. The interface is public. Now, if somebody would come up with a really grandiose idea and they'd figure out a new way to do square roots in calculators, then the new calculator that comes out, let's just say that a new one comes out, and it works exactly the same as the old one. But the old one, if you came in here and you put in 367 and you hit that key right there, it comes back, let's say, in half a second. And somebody has figured out a lot faster way that they can bring it back in a quarter of a second. So in other words, they can change the implementation, what happens behind the scenes that you don't see, to make the program run better. As long as my interface, as long as this doesn't change. So as long as the interface to the end user doesn't change, the implementation can change. And usually it'll be changed what? For the better, to make something work faster or better in some way or other. This encapsulation, all right, my internet has been flaky again already this morning. I don't know if it's the heat or not. All right. But when you encapsulate, you can kind of look at that you're sort of hiding the logic. Why? Because I shouldn't be able to change. I shouldn't be able to go in there and rewire my computer so that I can make 367 when I click that come up in the way that I do it. All right. So implementations are typically private. Interfaces are typically public. All right. Let's continue on. Going along very closely with this idea of encapsulation. And again, encapsulation means we want to bundle the data and the methods that work on the data together within a class. I mentioned to you earlier that giving you a very simplistic, in my simplistic, imperfect definition of object-oriented programming was using public methods rather to be able to modify private data. All right. Well, what does that have to do with anything? Well, if I create a class, that class by and large is going to have private data and public methods. But there are other types as well. You now hopefully you're getting an idea of what public means. All right. Kind of look at it, if you're still confused, as being like a public figure. All right. Now, I'm going to give you again a very unrealistic example. Okay. Let's say that I've got a problem with something that President Biden's doing, whatever it happens to be. Let's just say that President Biden comes up with some kind of a new uh, something new that he can interact. He doesn't even have to go to Congress for it, and boom, I don't like it. All right. Now, if I go and drive or take a plane to Washington and for a second, but imagine for a second that what I could do was literally ring the doorbell of the White House. President Biden would answer, and I'd be able to talk to him about this. In a true public way, that's the way it would be. I could go in and ring the doorbell just as well as you could go in and ring the doorbell. Again, I realize it's an unrealistic example, but I'm trying to let you know what public is. All right. Now, with private, all right, I literally, if I, go to somebody's house, I could ring the doorbell if I didn't know them. But if they answered, I couldn't just walk in the house. They have a right of privacy, right, or an expectation of privacy. And that's the way your data is. We only want to be able to usually modify our data, which we usually make private using public methods. What that does is it's going to take our object, whether it's a person object, or whether it's a house object, or whether it's a car object, or something else. And what that will do, call the object's state. Okay, the next thing then that's very close to encapsulation is abstraction. And the nice thing about abstraction, I think at least, is that it's typically easy to explain. And what I mean by that is we live our lives in a very abstract way, whether you realize it or not. Let's suppose that you get up in the morning, okay? And when you get up in the morning after you get yourself cleaned up and everything else, let's suppose that you have an 8 to 5 job. So you go into your garage, open up the garage door, you start up your car, you back the car up out of the driveway, or if you backed it in, you go out the other way. But let's suppose that you have to back your car out. All right. So you start the car up and you put it in reverse. Now, I'm no hardware guy. I don't know what happens when you start the car up. All right. I mean, you're doing some engaging, you're having the engine do its job, etc. But I don't know exactly what's happening. In the same way, when I take my car and I put it into reverse, I don't know what's exactly happening underneath the hood, so to speak. In both those cases, that information has been abstracted from me. Now, in the same way, imagine, for example, just for a second, the way that Amazon works. With Amazon, when you think of all the different parts of the company, all right, for instance, if I write code for Amazon so that when you click on things and you tell them to put them in your cart, they're put in your cart. Somebody else might write the code that when you put the things in your cart, they can basically start creating for you. Somebody else might write code that once you put in your credit card number or whatever, boom, now you can pay for it. All right. What does this have to do with anything? Well, if I'm the person who writes the code where you can put something in your shopping cart, I might have absolutely no idea of how the payment method works. All right. I just know that it does. And again, that's why I'm saying, you get up in the morning. Let's suppose you get up, you go to the bathroom, you flush the toilet. Most people can figure out what's happening when you flush the toilet, but exactly what is happening? Most people don't know. I don't know exactly what happens. All right. Let's suppose that you've got an electric toothbrush and you start that up. Do you know exactly what's happening when you do that? All I'm saying is much of the way we live our lives, the complexity of what we're doing, the details basically are hidden from us so that we can only concentrate on what we need to know. All right. And that's really what abstraction is. So they say, let's look at our car example again. As stated, it might have a start method attached to it. The start method, as it says, has some code that shows what happens when the method is called. But the object that calls it doesn't have to know how it works. It only has to know how to tell it to make it work. All right. So far, we have talked about encapsulation. And again, encapsulation involves bundling data The data is also known as properties. It's also known as attributes, but bundling that data together with methods, and methods are what we've been using and calling functions, but really they're behaviors. And you want to bundle the data and the methods together within a class. All right. We talked a little bit about public and about private. There's also something in between there that we can talk about now with inheritance, and that's protected. All right. Imagine that somebody tells you something and you say, wow, this is cool. Can I tell everybody else? And they say, yeah, tell all your friends. It's totally fine. That's public. If somebody else tells you something and you say, wow, that's really cool. Can I tell anybody else? And they go, no, you can't tell anybody. That's private. Finally, if somebody else comes up and tells you something and you go, wow, that's cool. Can I tell other people? And they say, you can tell people in your family. So you can tell your wife, you can tell your kids, you can tell your grandkids, you can tell your great grandkids, etc. That is what is referred to as protected. So, what does this have to do with anything? All right. So, we've talked about encapsulation, the bundling of data and methods within a class. We've talked about abstraction, which again is a way to hide the complex implementation details and focus on the essential features, what we have to know. All right, now we're going into inheritance. To inherit attributes and methods from a parent, kind of the way genetic inheritance works, but it's better than genetic inheritance. What do I mean by that? All right, well, as an example, and maybe not a good one, but the one I'm going to use is imagine that you've got two friends, a husband and wife. We're going to call them Bob and Betty. All right. And Bob and Betty have just gotten married. And fortunately or unfortunately, Bob and Betty each have a really, really, really big nose. All right. Now, they have a child. There's probably at least a chance that through genetic inheritance, let's suppose that that child is also born with, for a baby, a really big nose. Well, what can that child do about that as it gets older? Well, first, it can do nothing and just live with the fact that it's got a big nose. All right. Second, it can go in and have a nose job. But it's not like the child or the child's parents can take the nose off and say, you know what, I'd rather have them have this nose because it would look better on them. All right. But that is kind of what you can do when you are working with inheritance. Inheritance, again, allows classes to inherit attributes, which are data, and methods, which are behaviors from a parent. All right. And you're going to see this a little bit later today. But for instance, let's suppose I came in and did something like this. So let's suppose that I came in and I made a class and I called it vehicle. All right. And then after that, I made a bunch of other classes. So I made a class called car, a class called truck, a class called motorcycle, a class called boat, a class called bicycle. All right. We'll keep it like that. That's about all I can think of right now. All right. Well, all of these are some type of vehicle. So what I can do is I can define things up here that all of these would have in common. All right. I can define both data and methods. All right. Now, that's an example. Let me show you what I think at least is a better example. All right. So I'm gonna do something similar to what I just did, but I'm going to come in here and I'm going to make another new class that I'm going to call bank account. All right. Then underneath this, I'm going to make different kinds of bank accounts. I'm going to make a checking account. I'm going to make a savings account. I'm going to make a retirement account. And let's say we make I don't know, an IRA account. All right. Now I can come in and I can say, you know what? I've got different kinds of checking accounts. So I could have an interest bearing checking account and I could have a non interest bearing checking account. What I'm starting to show you here are typically what are referred to as class hierarchies. So this would be hierarchy level 0, this would be hierarchy level 1, and this would be hierarchy level 2. All right. Now going back to that kind of example that I showed you before, let's kind of expand on that a little bit. Let's say rather than a person, I make a class called employee. All right. And then I say, you know what? I've got hourly employees. I've got piece worker employees. I've got salaried employees. And I've got commission employees. All right. And then I go down here and I go, you know, my hourly employees, I've got both full time, let's just call it FT for full time, and I've also got PT for part time. All right. And I might have the same thing, a full time here and a part time here. Again, I might have a full time here and again, a full time here and a part time here. Now, some of these, sometimes when you create these hierarchies, they're scores deep. All right. You go down, you go down, you go down, you go down. Years ago, I took a class on object-oriented programming in downtown Milwaukee, Wisconsin. And the two most interesting things about that class were number one was the instructor. He was from India. And it's the first time in my life I ever met anybody who had the same first name as their last name. His name was Vieravan. And he was an engineer for Johnson Controls in Milwaukee. And Johnson Controls, they make a lot of the thermostats that you have for buildings. The reason I'm telling you this is the other interesting thing about the class. What Mr. Vieravan told us was that they were rewriting all of the code for Johnson Controls. And they were going from something that was not object oriented to something that was object oriented. All right. And during the break, I knew a little about object orientation, and I asked him, how many levels deep did you go? So again, there's 0, 1, there's 2 levels deep. And he said, we spent the whole first year taking everything that we did or do and breaking it down into a class hierarchy. He said, so far we're 500 layers deep. So you can see the more complex something gets, the more the more complex something gets, the more it's going from very general to very specific. All right. But if I came up here for employee and I said all employees have a first name, all employees have a last name, all employees have, let's say, a social security number, all employees have an employee number. All right. So again, I'm doing all this for our employees. Okay. Move that up a little bit here. like that. So I'd have a class called employee. All right, I'm just putting that in there so you can see. And I'd say all employees have this stuff. Okay. And let's make one more. And we'll say that all employees have a department number. These would all be right there. Those would all be attributes or data every employee would have. All right. But let's also say that we also come in here and we create a method. So this is data, but we create a method. We're going to call it earnings. All right. If I go and create hourly based off of employee, all my hourlies will automatically have access to all this stuff. If I create a piece worker based off of employee, they're all going to have access to this stuff. If I create a salaried based off of employee, they're all going to have access to this stuff. And if I create a commission employee based off of employee, they're all going to have access to this stuff. But the way hourly rate. All right. So normally the way that hourly employees earn money is the number of hours they worked times their hourly rate. Piece workers might, let's say, for example, it's how many pieces they make times the price for each piece. Salaried employees, and I'm an example of a salaried employee, we get the same amount. So, I mean, if I were to sit there and literally at my house work an extra 50 hours a week to get all this stuff set up for all of you, all right, if I were to do that, I wouldn't get any more money than if I didn't do any of that. All right. And finally, commission employees typically might have a salary, but then based on the sales they have and their commission rate. So we've got 4 different types of employees here in our mythical company. They each have a first name, a last. Again, I apologize for this stupid internet. All right. I will tell you that Tuesday I went in and I went into Rankin because we had an open house and I worked the whole day from inside of Rankin and my internet was going down there too. So it's not like this is just broadcasting here. All right. So we have 4 different kinds of employees. They all have these things in common. They have this in common, but the way they do their behavior, the way they earn is different for each type of employee. All right. So going back to our article there, they're saying, as an example, imagine that you didn't have something like inheritance. All right. So just looking at the example we just did, this one, we would have to create first name, last name, social security number, employee number, and department number separately for these, then for these, then for these, then for these, as opposed to doing it, at least creating it once and being able to not copy it, but inherit it. All right, in other ones. So inheritance is one of the best ways that we can use code reuse. All right. And again, inheritance is typically what's called an is a or an is an relationship. In other words, an hourly worker is an employee. A piece worker is an employee. A salaried worker is an employee. A commission worker is an employee. And typically, as you work your way down the hierarchy, children can do anything their parents can do. The reverse is not always true. And you'll see that as we go on. If that doesn't make a lot of sense, you'll see it as we go on. All right, the fourth pillar is called polymorphism. Polymorphism is a Greek term that means many forms. Okay. Now, I'm going to give you one more example here because I think it does a good job of explaining polymorphism. So we're going to go up here and we're going to do one more thing. I'm going to make one more thing up here. And I'm going to make a class that I call animal. All right. Here, let's start with a dog. And then we'll have a cat. And then we'll have a bird. Let's just keep it at that. We'll just have 3 classes. Okay. And we may or may not be able to come up with a lot of stuff in common with all animals. But one thing we could come up with is a method that's called speak. All right. But as you know, dogs speak differently than cats that speak differently than birds. All right. So if I called a speak method for a dog, it might say woof. If I called a speak method for a cat, it might say meow. And if I called one for a bird, it might say tweet. All right. But if I call these methods, I'm calling the same speak method. All right. So I could do like a dog speak, a cat speak, or a bird speak, but it knows what to do based on the type of object it is. In other words, a dog is not going to meow, a cat is not going to woof, a bird is not going to meow or woof, etc. Okay? So what polymorphism does is it allows objects of different classes to be treated as though they're objects of a common superclass. Now, I didn't mention this before, but this is typically called a base class, and these are called derived classes. Sometimes this is called a parent class, and these are called child classes. All right. And they even go by other names other than that. All right. But I just want you, again, I'm just trying to have you hear a couple of these things. All right. So when we go back and look in here, polymorphism gives us a way to use an object exactly like its parent, but keeping its own methods as they are. So in other words, as it says there, if we had a vehicle and we had a car and a truck and a motorcycle, we could define a start object, but the way you start a car, all right, is not typically the same way you're going to start a motorcycle, for example. All right. So as they mentioned in here, object-oriented programming may become, I don't know, maybe that article helped, maybe, but we're going to look at one more and then we're taking a break. This is how to explain object-oriented programming concepts to a 6-year-old. And again, I'm saying this again to you. I am not trying to insult anyone here. All right. Rather, I'm trying to give you start this with non-computer examples so that once we go in and start giving computer examples and start talking computer ease, so to speak, we've got a better idea of what it is we're working with. All right. So in this article, here's encapsulation. All right. As it says here, encapsulation is achieved when objects keep their state private inside of a class. What does that mean? That means the data, which are your properties or attributes, are usually private, and the only way that you can change them is through a use of public functions or methods. So as it says, each object manages its own state via its methods. Other objects and other classes cannot work with it unless you allow it through the use of things that are public. All right. Now, this example given here isn't really that great. All right. State, for instance, if we looked at a person as we did at the beginning here. I guess I thought we had that, but I don't remember where it went. That person class that we had, and I think that was over here. There we go. My eye color has not changed since I was born, to my knowledge. My hair color has not changed since I was born, to my knowledge. My height when I was born was probably somewhere around 12 inches. Now it's at 72. My weight when I was born, I was told I was a big baby, was about 10 pounds. Now it's a lot more than that. My gender has not changed. My marital status has changed over time. All right. So all of these, again, would be data or attributes. The way they'd be set up is they'd all be private, and I'd have to use special functions or methods to change them. All right. Again, going back, classes are blueprints, or as Mr. G calls them, cookie cutters. Objects are instances of a class, or as Mr. G would call them, the cookies. Abstraction, as it says, is a natural extension of encapsulation. All right. It says applying abstraction means that each object should only expose what people need to be able to use for its interface. And they give an example here. It says, think about this. And I know we have this at Rankin, just like you have it at really probably any place of employment. There's a coffee machine there. And I don't mean when I say a coffee machine, I mean literally a stand against the side machine. You put in your money, you click a button, and you tell it what kind of coffee you want, and it makes that coffee for you. Probably very few people know exactly how that works. Not only that, think about the actual implementation of using a coffee machine. What if you had to press a bunch of buttons? What if you had to press a first button that would make the cup come down? Then you would have to press another button that would have to bring in the coffee grounds. Then you'd have to press another button that would bring in the water. Then you'd have to press another button to heat the water. Now that's only 4 or 5 buttons. But again, looking at that example we used before about starting up a car, etc., you could see how complex in a hurry. You wouldn't want to do that anyway. What you'd rather have is a simple, easy to use interface. For example, when we talk here about using a when we talk here about a coffee machine, I just want one button I have to click. Put in my money. If I want a coffee with cream, maybe there's 2 buttons. Maybe there's one for coffee and another one for cream, or maybe there's several different buttons there, but one says coffee with cream. I want to do that and boom and be done with it. As it says, this mechanism should be easy to use and should rarely change over time. Think of it as a small set of public methods which any class can use without knowing how it works. Very similar to the example that I gave you before, all right, when we talked about the calculator. They've got another one here. They say, think about your phone. Most people don't know how their phone works. All right. I mean, if you say, well, I do, okay, fine. Then when you turn your phone on, do you know exactly what happens inside of the phone to make it do what it does? Or if you go and choose that you want to go to the internet from your phone, most people couldn't tell you exactly behind the scenes what is happening to make that happen. So as it says, for example, cell phones are complex, but using them is relatively simple. And again, if you change the implementation, as long as the interface doesn't change, who cares? Inheritance, we talked about before, that a lot of times when you create something, you'll create something else that's very similar to what you created to begin with. So, as it says there, you can reuse common logic and then bring in new unique logic. All right. So a child can do everything the parent can do and typically more. The child class, as it says there, reuses all the fields and methods of the parent class and can implement its own as necessary. And they give an example, not even that different from what I showed you. All right, you've got a person, and each person has a name and an email address. That means that automatically each teacher and each student has a name and an email available to it. The teacher also might have a subject that she or he teaches. The student may have one or more classes that they're taking and one or more grades for those classes. The teacher, you'll notice there's a private teacher. All right. So it says there, if the program needs to manage public and private teachers, you can implement it as a class hierarchy. And it's kind of what I just mentioned to you. Finally, polymorphism. And as it says there, polymorphism is a Greek word that means many shapes. All right. It says, we already know the power of inheritance and happily use it, but here comes the problem. And that is, let's look at the employee example that I gave you before. I want to be able to call one method called earnings, and I want it to work whether the employee is an hourly employee, or they're a pieceworker employee, or they're a salaried employee, or they're a commission worker employee. As it says here, this can be solved using polymorphism. It gives a way to use a class like its parent. So if I define earnings up in the parent, the child can use it. Typically, they'll have to do some tweaking to it, but they can. That's pretty much it for this article right here. All right. So hopefully that helped a little bit to get you started. All right. Now, before we go in and actually do come in and try to look at, chapter 12, let's look at something that when I bring this up right now, you're going to think, why are you doing this? We already know how to do this. All right. So I'm going to get, I think this one right here I made a goofy example earlier. I don't think I need this anymore. No, I don't. So I'm going to get rid of it. So I'm going to create a new folder here on my desktop, and I'm just going to call it Intro to OOP, because that's still what we're doing. We're still in the introductory phase. Okay, there it is. Oops, screwed it up. So let me try it again. Intro to OOP. And as of right now, as you'd guess, there's nothing in there. It's totally empty. Okay, so I'm going to come in here and I'm going to start up a new Visual Studio project. Let me get rid of that calculator. I don't need it. So I'm going to come in and start up a new Visual Studio project. All right, I'm going to create a new project. All right, and I'm going to make it a Windows Forms app. You'll see why in a minute. And I'm just going to call this OOP Project 01. Okay, and the solution, I'm going to call this OOP Solution. All right, and as far as where I'm going to put that, I'm going to go to my desktop. There is my intro to OOP. Okay, now this project is going to be so simple, you're going to wonder why I'm doing it. There is a reason. So please bear with me. All right. All right. First thing I'm going to do, as we always do, is I'm going to come in here and I'm going to rename the form to FRM OOP Project 01. Yes, I want to change the name. All right. Usually this is we change the background color so you can see what's going on here. And I'll just make this yellow. All right. Next, I'm going to change the text, which just says Form 1. And I'm going to make this C# object oriented programming OOP example number 1. Okay, so now that's in there. All right, this example is going to be so simplistic, you're probably going to wonder why I'm doing it. Please bear with me for just a minute and you'll see why. Okay, all right, so I'm going to come in here and first I'll put in a button. All right, and I'm going to put that button, make it nice and big right here. All right, and I'm going to call that button BTN greeting. All right, and the text on the button is going to be just that, greeting. All right, then I'm going to add simply a label. Put that label up here. All right, as always, there's only going to be a single label in here. So I'm going to call this LBL name. And the text on it is going to be the word name with a colon. All right, it's hard to see that. So as always, I'm going to make this a darker shade of yellow. All right, so you can now see it better. And I'm going to set the auto size. Whoops, sorry. Try that again. The wrong line. All right, and I'm going to set the auto size to false. You've seen this countless times before. I know it. All right. So I've got LBL name, BTN greeting. Okay. And now I'm going to come in and I'm going to add a text box. I don't think this needs to be that wide, so I'm going to narrow that down like this. And now I'm going to put in a text box. I may have to widen that out. I don't know. So let's come up and put in a text box. All right. And we'll make it about that wide. There we go. And I'll widen this out as well. All right. Now I'm going to take everything that's in here. Again, you've all seen this many times. And I'm going to come in here and I'm going to go over to my font property here. And I'm going to change the font size to 24, the font style to bold, and the font to Arial. Okay, whoa, I don't know what I did there. Instead of 24, I made it something else. Oh, I changed the form. Okay, let's try that again. Let's highlight all of these. All right, and we're going to make all of these 24, bold, and Arial. You've seen this quite a few times before. Let me move that up. There we go. I'll lock my interface into place. Okay. This has been named. This has been named. No, it hasn't. So we'll call this TXT name. We'll do that in a minute. And that is called BTN greeting. Now, what you may or may not know is, and we looked at this a little bit, but not in too much detail. I'm going to open up this project designer file. Okay. And if I go down to the bottom of it, you'll notice that what I have in here are three things. Private systems.forms.windows.forms.button greeting, and I got to see if I made that upper or lowercase. If it is, I'll change it. We've got another one in here. All right, system Windows Forms label LBL name, and a system Windows Forms, another private text box 1. Now I'm going to close this. I'm going to, whoopsie, let me try that again. Cancel here. Let's close this. And then let's come back to here. All right, so there was my label. All right, I'm going to change the name of the text box to TXT name. All right, And I'm going to go back to my button. And I did make that a capital B. So I'm going to make that a lowercase b. Okay. All right. So I've got all that. But now notice if I go back to my file again, to my designer file, that's been changed. It now has all of this. I'm going to keep this up there for just a second. There's a reason for this. Now I'm going to come in here and I'm going to say, I'm not going to worry about modules or anything. And I'm just going to say here, if txt name dot text dot trim equal nothing, I'm going to make quickly a message box dot show that's going to say, please enter a name. All right. And then I'm going to say no name input. All right. And then I'm going to have my message box okay. And it's not really an error, so I'll make it an information. All right. And I'm going to say return. Okay. You got that. So that's all done. If we get down to here, so what are we doing here? We're checking absence, I should say presence or absence of a name in the txt name text box. Pretty obvious. So if this is the case, the name text box is empty. You already know that. Otherwise, if we get down here, we don't need an else. We can just do another message box. All right, so we'll do another message box right here. And I'm going to change what it says, of course. But we're going to say message box hello plus txt name dot text. And we'll change this to name. So I'm going to save this and run it. And I'm not trying to waste anybody's time here. All right, let's do what we always do, just for consistency's sake. So we only have one button here. So let's make that our accept button. We won't have a cancel button because we only have one. I'm not going to come in here and put in a clear and put in an exit. I don't care. So we've got all that. Let's set our start position to center screen. We will set our tab order to 0, 1, 2. Okay, so view tab order 0, 1, 2. Again, a view tab order. All right, so let me go in, let me close this, and let me run the program. All right, if I leave it empty, I get no name input. Please enter exactly what you. All right, I probably should have set the cursor there too. If I come in and put Jeff Scott, it comes in and it says, hello, Jeff Scott. Again, nothing magical there. There was nothing magical there. So again, I'm going to say here, txt name dot focus. All right. And here, txt name. Well, that's nice. Let me go back and change that. So we will call this just txt name, not z name. To change it everywhere. So finally, let's take this and let's center it. All right, make sure everything still works. So with nothing, we get our error message. and there's our cursor. When we put in our name, we get hello followed by that. Okay, and you're like, that's fine, Jeff. Why are you showing us this? I want to go back to this file right here, because what you may or may not realize is this isn't all that's here. Notice it says Windows Form Designer generated code. Now I'm going to click this plus sign. And lo and behold, look what happened. Object-oriented programming. All right. Here's our button equals new system.windows.forms.button. The label equals new system.windows.forms.label. The text box equal new system.windows.form.textbox. So what this is doing right here in that initialize component, you may or may not remember, but that initialize component is done right here when the program starts. So what that is doing, this right here is instantiating or creating three different objects. It's creating BTN greeting, which is an object of the button class. It is creating LBL name, which is an object of the label class. And it is creating TXT name, which is an object of the text box class. All right. Now, I had a student who asked me this morning, they said they had a problem with this right here. I'm not even sure what that does. I'd have to look it up. And I'm not going to right now because I want to go through this. So again, I'm not going to put a comment here. This is a system file, but I am instantiating three different objects right there. All right. Then what I'm doing to each of the objects in here, we are adding data or attributes to our object. We are adding a font property or attribute to the button, a location to the button, a name to the button, a size to the button, a tab index property to the button, text to the button, a use visual style back color to the button. And then this basically is adding an event handler to the button. If you say that, in that you don't even have to worry about, but the point is, in our initialize component, we are first instantiating three different objects. Then for each object, we are setting its attributes. So there's the ones we're setting for the button. There's the ones that we're setting for the label. And there are the ones that we're setting for the text box. In addition, notice there's other ones. These are for the form. So every time I go in there and change something, all right, every time I go in there and change something, this should get updated. Notice this text here says C# object-oriented programming example number 1. All right, right there, you see it. So I'm going to come back here. And in my design mode, I'm going to click on the form. Then I'm going to come back in here. And in my form, I'm going to find that text property. And I'm going to change it to AWD1100 dash C# object-oriented programming, etc. So I hit enter and it changed up here. Now let's go in here. And notice how it changed. It was immediately updated to add this. All right. Now, why am I taking the time to show you this? I purposely created a very, very, very simplistic example. All right. And I did that to show you that this is the kind of thing we would have done on day one. But even back in day one, so even back then in day one, we were, we actually were, we actually were coming in and creating stuff that was object oriented from the get go. All right. So object orientation uses classes. All right. These classes create objects. In these classes, we encapsulate or we kind of wrap or bundle together data, which are typically known as attributes, and methods, okay, which are basically behaviors. Now, once we create objects, all right, objects have the ability that they can hide their implementation from other objects. All they show is their interface. All right. This is normally called encapsulation and or information hiding. It goes by different names. All right. Now, sometimes you get objects that can communicate with one another across very well-defined interfaces. For example, okay, when you get in your car, you've got a very well-defined interface. You know what the steering wheel does. You know what the accelerator does. You know what the brake does, etc. But the details of how those are done, the actual implementation that makes them happen has been abstracted. All right. The implementation details have been hidden within the objects themselves. All right. And most of us, as I mentioned earlier, live our lives in a very abstracted type of way. All right. Most of us do that. All right. I mean, you can drive a car without knowing how the engine works, the transmission, etc. work. All right. But, and it's because it's got a very well defined interface. The implementation has been hidden from you. Now, so far in this class, the class that you're in right now, AWD 1100, up until today, up until today, virtually everything that we did was non-object oriented. Yes, we've been using object oriented stuff like I'm just showing you here, but it's all been in the background. We've been writing things in what are called a procedural method. All right. But even though we have been doing that, as I already showed you, we've been working with classes. And really, to even show you it a step further here, if we go to here and I come here and I can grab any of the things that are in here. So if I grab the text box in my properties window, notice the name properties. These are all the attributes for that text box object. All right. And if I come into here and I double click on my greeting and I want to do something, I'm not going to actually put in more code here. But if I come through here and I say BTN dot, this has in here both attributes that are available to me and methods that are available to me. All right. Typically, the ones that are in here that have the lightning bolt, all right, typically those are what? Right? Those are methods. So if I come through there and choose this one, back color change. Now don't worry about it. It's expecting something here, and I'm not giving it that. So if I said like equal, something like color dot something or other, gray. Now, it may not even like that. I don't know, because I've never worked before with back color change. But what I'm trying to show you here is when you type in the name of the object, and again, this is the way I want you to start thinking about this. This is a button object. BTN greeting is an object. It is a child of the button class. So when I put in the name of the object and I put in here dot. In fact, let's do this because typically I wouldn't change it in here, but let's come back here and let's double click. All right, now I'm in the load event. So I'm going to say my BTN greeting dot, is there a back color? Back color equal, is there a system colors dot, is there a black? I don't know. System colors dot, and I just say colors, colors dot color dot black. Okay. And then I'll say BTN greeting dot for color equal color dot white. All right. What did I just do in my program? Easiest to run it and show you. Notice I've changed. It works exactly the same, but I've made interface changes. In other words, what you see is different. Instead of having a gray button and having that gray button have black text, I now have a black button that has white text. And how did I do that? I did that by going over, and for the button object, I had the name of the object dot, then I had the name of the property I wanted to change. And I did it again. Back color and fore color are just two examples of properties that I can change. I could just as easily have come in and change those things in here. All right. You'll notice if I look now, fore color, it still says is black, and back color, it's, I don't know what it says. It looks like over here, the back color is yellow. I don't even know why, but you get the idea, hopefully. All right. So from now on, you kind of got to look at it that when we're working in C#, the unit of programming that we're going to be working with is the class. The class, again, depending on what you want to call it, the class is either, all right, what I call, what Evan calls the cookie cutter and what I call the blueprint. From the class, we are going to instantiate or create objects. And objects are instances of the class. The act of creating objects from a class is called instantiation. Again, I'm using my definitions. All right, the class is a blueprint. The object is an instance of the blueprint. Just like if we had that house plan, that's the class. The actual house object itself, that's the object. And as I mentioned, Mr. G, Mr. Gudmested, calls them the cookie cutter for the class and each individual cookie for the objects. So these objects are created from classes, and the way the object works, that meaning the data and the methods, they're encapsulated within the boundaries of the class. That's the encapsulation. All right. What we have been doing thus far is we've been doing this. This is what we've been doing so far. All right. But the way it's going to start changing now is we're going to start creating our own classes and objects. Most C# programmers concentrate on creating their own classes. And basically, you can kind of look at a class as being our own user-defined data type. All right. Sometimes they're called programmer defined types. So these classes will typically contain both data and methods that can be used to manipulate that data. All right. Now, each object then, let's suppose that for our class, we create both data and methods. So each object is going to have its own copy of that data. These are going to be called member variables or instance variables. They're even called fields. Just as when we looked at this to start with today, each person has their own eye color, their own hair color, their own height, their own weight, their own gender, their own marital status. Okay? All right. So an instance of a class is known as an object. So what we're going to be doing now is we're going to focus a lot of our attention on how to create classes. Sometimes, as a programmer, what you're given are a set of requirements, literally with words on a piece of paper, where you're given a bunch of requirements: do this, do this, do this, do this, and do this. So if you do something like that and you are coming through when you are doing that, so if you are coming through when you are doing that and you are starting to go through there and look at different things, all right, sometimes at least, what'll happen is when you start to create your own classes, again, this is kind of what people at least at times will do, is they will look for nouns. They will look for nouns. What do I mean? Noun: a person, a place, or a thing. Quite often, those will become the classes. Not always, but quite often those will become the classes. When you look at verbs, and if you remember, verbs are action words, those will often become the methods. Some of the nouns will become the classes, some of the nouns, the data. It just depends. All right. And one more time, I want to go over these four pillars one more time. All right. We just finished talking a couple minutes ago about abstraction. And again, abstraction is the concept of wrapping up complex actions or action, whatever, into something simple. All right. If something is abstracted away from you, you see the interface. You are not typically, unless you wrote it, you are not privy to the how the actual implementation works. I don't know when we just did this, all right, and we added in there that code. I don't know physically how it went when I ran the program and changed that color from gray to black and from black to white. There's a system dot drawing, and there was something that was done in there with that. I don't know. And not to be funny, I don't care. All right. Now, abstraction and encapsulation support one another. Really, if you don't group things together, you're going to have a harder time extracting them. All right. And, there'll be stuff that gets passed back and forth. You'll see this once we start creating our own objects, etc. But as much as you can, you want to take the state of the object. That state of the object are basically the values of all of the instance variables. So for my current state, eye color is blue, hair color is brown, height is 72 inches or 6 feet, weight, sorry, it's 250 pounds, gender is male, is married is true. All right. That's my current state. the smaller I can make this. In other words, I want this person class, but you'll notice there's a lot of stuff that isn't in here. Right now, when you create a class like this, all right, the only thing that the class knows about are these things. So notice we've got eye color, hair color. I don't have, as an example, it just came to me, I don't have skin color in here. So skin color wouldn't be known to a person object because it's not in there as a piece of data. And let's say that I say that all persons, all right, let's say that I even come in here and I put in a couple methods. So I say they can all eat and they can all drink and they can all sleep. The first thing to notice here is they all have parentheses there. If I left them off, if I left the parens off here and here and here, the system would think they're just more pieces of data. But having the parentheses in here means that I can pass things in. So for example, I can say eat cake, all right? Drink water, sleep, and maybe I put. Finally, we went in and we talked about polymorphism. All right. And I already mentioned to you that polymorphism means many forms. All right. It's sometimes also known as a condition of occurring in different forms. So we're not talking form here like your form, FRM something. We're talking about different forms. It means that we can call the same method on different types of objects. So like that speak method that we looked at earlier. All right. And we said that we can call this speak method. And if it's a dog, it knows how a dog speaks. If it's a cat, it knows how a cat speaks. And if it's a bird, it knows how a bird speaks. All right. So even on here, I made this much more simplistic than it is. So what do I mean? Well, if I came down here, really, when you think about it, for example, there's a dog that's called a Saint Bernard. There's a dog. Let me move this one at least over here. All right. So there's a dog called a Saint Bernard. There's another dog that's called a. So you can see I'm going from as general as you can get to more specific to more specific. And if there's different kinds of Saint Bernards, all right. So here's one because this is the way things are today. So I'm going to put in here a doodle. All right. And what did I put that in there for? Well, there could be a golden doodle, a Bernedoodle, and I'm sure there's tons of other ones. But you can see that with every time as I'm going down on the hierarchy, all right, now all of those dogs, regardless of their type, when we called speak, would be able to say woof. And I could do the same thing for cats. A tabby, a calico. I'm not a cat person. I don't know. For birds, I could say parrot, duck, etc. Now, different birds could speak differently, right? I could have a parrot that could maybe even actually say some human words. I could have a hummingbird that would tweet. All right. I could have a duck that could quack, a goose that could honk. So they could all react the way they're supposed to react to the speak method. They all go together in the sense that all child classes will have the methods and attributes that were defined in the parent class. They may do what's called override those methods. All right. Okay, so let's go in and actually attempt. I don't know if the last example that I went over with you, I don't know if that particular example you'd actually, this one right here, whoops. Let's go in and let's write that person class that we had. Okay. And so I'm going to close this one. So let me do a file, save all. And I'm actually going to run this twice or write this twice. All right. Now, could I do that, do all of this with just one person class? The answer is yes, but it would take more work than I want to show you right now. So what I'm saying is I'm going to come in here and the first thing I'm going to do is I'm going to come in and create another project. And this first one is going to be a console app. All right. And I'm going to call this OOP person console. And then I'm going to go back and I'm going to try at least to rewrite it as a GUI app. All right. So here's my OOP person console. Click create. You've seen all this stuff before. I'm not going over any of this stuff. All right. But let's start working on this. Now, I'm going to come in here and create a new class. What do I mean? This is a driver. You're going to really start to see now how main is a driver. You'll see it in a minute. But I'm going to come in here and on my OOP person console, I'm going to right mouse click on here and I am going to choose add. And down near the very bottom, all right, and it asks for a name. And I'm going to type in person.cs. So here's a brand new class that it's creating for me. Notice it says here namespace, which is where it's going to be located. It's under OOP person console, the same name as my project name. If I go back to the other one, same namespace. They're sharing a namespace. All right. And in here, what I'm going to put in, we can write this in so many different ways. But when we first do it, I'm going to write it the way that it's written. It'll work the way that it's done in other languages. And there's a reason I'm going through this the way I'm doing it. So typically, I don't want to talk about internal right now. What we're usually going to do is we're immediately going to change that word internal to the word public, which means that this class can work with other classes. All right. Now I'm going to show you in here. This is not the way that we would always do it, but this is the way I'm going to do it. All right. So I'm going to come in here and what did we say each person had? If you remember from before, we said each person had an eye color, a hair color, etc. All right. Let's add to this and then let's just put in there that each person has a first name and a last name. Okay. So we're just going to add those things. So we're saying that each person will have this stuff. All right, we'll add these in just a bit. So this will be our person class. We'll have 1, 2, 3, 4, 5, 6, 7, 8 different types of data. Okay. And it'll have these 3 behaviors. So what I'm going to do is I'm going to put all of this into my program, but I'm going to put it in as a comment. So I'm going to put it in at the top here. All right. And I'm not doing it to confuse you. I just want to be able to see everything that I'm working on at one time. All right. I'm not going to worry about going back and adding the asterisk, etc. All right. So I'm going to come in here and do this. I'm going to say private. And the first is the first name. So string underscore first name. Let me do all of them and then we'll come back and talk about them. And you'll notice that the IntelliSense, at least somewhat, is kicking in already. So I'm also going to have a private string eye color, another private string. Notice it's already figured out a gender for me, but before that gender, I'm going to want to put in a hair color. All right. Another private, this will be an int, and it'll be height. Another one, notice it thinks it's width, but I'm going to make that weight. All right, so I now have first name, last name, I name, hair color, height, weight, gender, and I finally need my other one that is married. Okay, so I've got all these in there now. You'll notice when you look at them that every one of them is gray. And what that means is none of them right now are being used in my program. They have no references to them right now. We're going to change that in just a moment. I'm just lining everything up so you can see everything that's in here. And I'm going to put a comment in here that says instance variables. Because what we're going to do in just a moment is we're going to go switch back to our main and we're going to create some instances of a person. All right. Now, like I said, the way I'm going to show this to you, it will work, but this isn't typically the way it's done. There's a reason I'm showing it to you like this. So I'm going to put in here public string get first name. Okay, just like that. I don't know why it's doing that, but it's saying in here, oh, okay, return underscore first name. Okay. All right. And I'm going to make one of these for everything that I have here. Notice how that's not grayed anymore. So I'm going to make one for last name, eye color, hair color, etc. These are going to be called my getters. And they're also called accessors. Okay. So I need 1, 2, 3, 4, 5, 6, 7, 8. I need 7 more of these. Okay. Notice it already is trying to do a get last name for me. Now I'm going to just copy this one and I'm going to paste it in. So it's in there 8 times. It's going to give me errors until I rename them. All right. So they're all going to have errors. Don't worry about that. We'll fix it right now. This will be our get last name. So we'll have to make sure we check all these and we return last name. All right. Then we had eye color and hair color. And you'll notice with each one of these, when I change the name, not only does the error go away, but now this is blackened. All right. So this will be get hair color. And of course, this will have to change as well. All right. So after eye color and hair color, we've got height, weight. And it's giving me an error because height is an integer. All right. That fixed. Now I'll have to do the same thing for weight. So this will become get weight. All right. And finally, we've got gender and is married. Good. gender, I'm sorry, not gender, is married is a Boolean. So that's going to be get is married. And again, that's what we're going to be returning. All right. So I'm looking here. What doesn't it like? Is married. Oh, we made that a string. That should be a bool. That was my error. Okay. So I now have no errors in here. And I have 8 different methods. Each method has nothing passed into it. Each method is returning that instance variable. So it'll return the value of first name. It'll return the value of last name. It'll return the value of eye color, the value of hair color, the value of height, the value of weight, the value of gender, and the value of is married. So those are our 8 getters or accessors. We also not only want to be able to get or access a value, we want to be able to set, or what's called also mutate, a value. So I'm going to come in here just because it'll be faster. I'm going to copy every bit of this. I'm going to get errors up the wazoo in just a second. But I'm going to come down here and paste that in. And then I'll start making my changes. Don't worry about it. So these are going to be called my setters. And they're typically referred to as mutators. They do not have a return type, and they are called set. All right. And you get passed in some kind of a value. So this will have passed into it a string that we'll just call value. All right. And we're going to say here, first name equal value. And you'll notice that my errors are gone. So let me take this one now that that works, and we'll copy it down for the other ones and just make changes to all of these. All right. So we've now got our, what I did there. We've got our set first name. Okay. So I'm going to grab that. And now I've got 8 of those. Again, I'm going to have to change each one of these. So there's our set first name. We'll have a set last name. Notice how the errors have gone. We'll have a, eye color, hair color. We'll have a height and a weight. These will have to have an int passed in as the value for both. And this will have to say height. And this will have to say, I'm sorry, this is now not set first name, it's set height. All right, and this will be set weight. And finally, we've got gender, which was another string, so set gender. So this will be gender. And this will be, let's see. This will be is married. So this will be a bool. This will be is married. And this will be set is married. All right. So we now have 8 getters, 8 setters for each one of these. All right. But we also said earlier that we wanted to add in here also. So these are all done. these 1, 2, 3, 4, 5, 6, 7, 8. We're now going to be able to both bring values in and get values out for those 8 fields, but we don't have these. All right. So what we're going to call all of these, all right, is we're going to come in for each one of these. We're going to make a method. We're going to have one that's going to be called eat, one that's going to be called drink, and one that's going to be called sleep. All right. So let's come in there and write those. I'm going to write them underneath these. All right. So these will be, I'm going to call these my class methods. All right. And I'm going to say here, public, void, eat, and we'll give it a string. We'll call it food. And we're going to say, for now, we'll just use system dot out dot let's see, I can now get rid of all this. That was just kind of taking up space. So we need system. I think that's the only one of these we're going to need. So I'm going to use using static system.console as well. Console. All right. And I'm going to see if it's going to allow me to do a write line in here. So write line. And I'm going to say, get first name plus a blank space plus get last name plus, and I don't want to just say food. Okay, I'm going to go put this on another line. I'm going to say is eating food. Okay, so if I pass in cake, for me, it should say Jeff Scott is eating cake. Okay, we'll see if it works in just a couple minutes. Then we'll make another one, another public void, and this one will be called drink. And we'll put a string in there, and I'll put in liquid. And I'm going to say is drinking, and that'll be liquid. All right, and I'm going to copy this in here one more time. I am going to take everything that I'm doing here, and I'm going to make a copy of it. All right, it will be put into a GitHub repository by the end of the day. Finally, this one is going to be called sleep, and it's going to take an int, and it's going to be, I'm just going to call it for something simple, num hours. All right, so here we're going to say is sleeping, and this will be num hours plus hours. Now, if this works, I'm going to set myself up as a person. Okay. And when I set myself up as a person, I'm going to set all these things. And then I'm going to call all of these methods to say I'm eating cake, I'm drinking water. Let's make it milk because water with cake sounds kind of gross. We'll say milk, and I'm going to sleep for 8 hours. So let's see right now if all of those will work. All right. So you can see everything that's in here. Okay. We had instance variables. So each time I make a person, each person will have his or her own first name, last name, eye color, hair color, height, weight, gender, and marital status. Those I can get by calling the get methods for each one of these things. And you'll notice that each one of them has nothing passed in. Each one of them will return something, and the return type has got to be specified. And they start with the word get. They're called accessors because they're not changing anything. They're displaying something. Then we've got our sets. These are changing things. Changing them is also referred to as we're mutating. We're changing their value. So here we're passing in something for the first name. That'll become the instance variable's first name. Same thing with last name. Same thing with eye color and hair color. All right. Same thing with height and weight. You'll notice there we're passing in numbers. Then gender, which is another string. Then marital status, which is a Boolean. Finally, we've got three class methods. Why did I call those class methods? Where really all of these getters and setters, all right, they're basically class methods too. They're all public. They can be used by any person object that we create. Can use get first name, set first name, but they can also use eat, drink, and sleep. All right, so I'm going to attempt to come in here. Now, let me do a file, save all. And now I'm going to go back into here. I'm not going to worry about, again, I'm not worrying about being modular here. All right, but this is the first time you're going to see this here. I'm going to say this, person one equal new person. I am just refer to this object as person one. Could I have called it Jeff? Of course I could have. I could have called it anything I wanted to, but I'm purposely giving it a generic name. All right. When I call this, just so you know, when I call this right here, when I call this, all right, what's happening is the system is creating this for me, something called a constructor. In fact, it's actually called a default constructor. And what's it doing? Actually, a lot, even though it won't look like it. So it's person, all right? I'm sorry, it's public, that again, public, fix that in a minute, person, all right? And it's actually doing this. And it may look like it's not doing anything. That would be the wrong thing to think of. All right. In fact, I don't do that here. Let me bring that where that actually is. I'm getting an error because that's actually what's happening in here. Notice, all right, it should be a little p, and that's why I'm getting an error. There's no errors here. When I create a new person, this is being called right here. And you say, that's kind of stupid. It's not doing anything. Yeah, it is. Since I made it the default constructor here, it's setting any string value to null. It's setting any integer value to 0, and it's setting any Boolean value to is married. If you've got a default constructor, and if that's the only one you have, you don't even have to put this in. It gets put in for you. All right, I'm just showing it to you. But what I want to show you now in here is this. So if I come in here now, after I did this, and I instantiate a person, and I say, I want to just show you all of this. System dot con, I don't even need all that. Remember, it's right line. And I'm going to put in here oops, I guess I need to put that using static system dot console in here. Using static system dot console right there. Okay. So now I can just say right line. And I'm going to say the first name of person one is plus. Now, person one. Now, notice when I put this in and I hit the dot. All right. When you look in here, notice what we have. All of our gets, all of our sets, and some other stuff. Well, what do I want to do? I want to get their first name. All right. All I'm right here is to prove to you that when I instantiate a new person object, the first name will be empty, the last name will be empty, etc. So I'm going to put this in there. All right. So I've got the first name of person one, the last name of person one, and that'll be get last name. All right. Then we have why I'm just my brain's not here today. I apologize for that. Eye color and hair color. So the eye color of person one, and that'll be get eye color. All right, then we'll have the hair color of person one. And that'll be get hair color. All right, then we will get height. All right, it'll work. All right, but we also could come in here and say dot toString. All right, because it's a number. And we'll do the same thing for the weight. You'll notice what I'm doing is I am in one file, my main, and I'm calling stuff from my class. And since I instantiated this, it knows that get first name, etc. It knows that all that stuff is there. All right. So the last ones that we have is gender. And finally, we'll say marital status. All right. And we have, I think we called it is, sorry, not marital status. Get is married. Okay. Now you'll notice when you look in here, I have no errors. Hopefully everybody notices that. All right. There are no errors in here. I'm just lining stuff up so you can see what goes with what. All right. If I did this the way I think I did, it's going to say the first name of person one is, and it'll be empty. The last name of person one is, and that'll be empty. The eye color of person one is, and that'll be empty. The hair color of person one is, and that'll be empty. The height of person one is 0. The weight of person one is 0. The gender of person one is empty. And the marital status of person one is false. If that all works the way I think it's going to work. Now, let's make sure that at the end we put a read line in here so it doesn't just spew right off the page. All right, so this is, I'm going to put in here, print out all default values for person one. Okay, let's see if indeed what I thought was going to happen is indeed what's going to happen in here. Oops, it's running the last program. Sorry. All right, we'll change our startup project. Right mouse click, set as startup project. There we go. All right, so let's see if it worked. Okay, so it defaulted. Any value that was in here that was a string was automatically defaulted to the empty string. It defaulted any value that it was in here that was an int, it defaulted it to 0, and it defaulted the value of any Boolean to false. That's exactly what I figured would happen. All right. So I'm even going to take a screenshot of this. In fact, let's do it like this. So we will put in here exactly what we have right there. So I'm going to say here, right line. I did that, but I did. And I'm going to put in here, print all default values for person one. And now it says that at the top. All right. Okay, that's all good. Now, what I'm going to do now is I'm going to come in here and I'm going to take everything that we have in here, all these right lines, and I'm going to comment them out. You can uncomment them yourselves if you want to kind of take a look at it later. So I'm going to comment all of these out. There they are. So if I run the program now, I'll have no output. All right. Now I'm going to call the getter for each instance variable for person one. All right, so I'm going to be calling, I'm sorry, let me call the setters. I want to set them. If I call the getters, it would look just like this. That basically is calling those. We're calling the getters here. All right, so we're all them out by calling the getter methods for person one. Okay, that's exactly what we're doing there. So let's come up and let's do this above here. Okay, in fact, we won't. We'll do it right here. We'll call this setters. So person one dot set first name. And what do I want to set it to? Jeff. All right, set last name, and I want to set it to Scott. Next was eye color. We'll set that to blue. And then we will do the hair color to brown. Next, we will set the height and the weight. That'll be 72. And that'll be 250. And finally, we've got gender. Okay, so now we've set all of them. Now notice if I come back in and call the getter methods again, they should all now be set, unless I screwed up, which with me, as you know, is always possible. So I'm going to say call the getter methods. And I'm going to uncomment all of these. All right. Now it'll say the first name, last name, the weight, the height, etc. These should all have values now because they've all been set up here. So we're going to come back in just a second and look at these. All right. I got to change that, print out all the default values. So the first name is Jeff, last name is Scott, eye color, hair color, height, weight, gender, and marital status. They've all now been set. So what I have shown you in this example, all right, what I have shown you in here, okay, so this one can be print all the values for person one using getters, and this one is after using setters. So it's using getters after using setters. All right, look a little bit ugly, but that'll now say this. Print out all the values for person one using getters after using setters. All right. Now, hopefully, what I've shown you so far makes sense. It's different. It's not what we've been doing previously. All right, let's see if we can do our last three methods. All right, and I'm going to say person one dot eat. Okay, and it doesn't like something, so we'll check it in just a minute. Cake. Person one dot drink milk. And person one dot sleep, and I'm going to put in there 8. All right. Let's see after running this now what's been added. So here I'm going to call the non-getter, non-setter methods of the person class. All right, so let's look at it now. Now notice I've got the same stuff as before, but Jeff Scott is eating cake. Jeff Scott is drinking milk. Jeff Scott is sleeping 8 hours. Now, good, bad, indifferent, whatever you want to call it. What I've shown you so far isn't typically the way that this is done. All right. So you might ask, and it would be a very, very, a reason for asking would make a hell of a lot of sense. Then why the heck did you show us? All right. Well, what I want to do is I want to write this same program, and I'm doing this a little bit differently. Okay. And I'm going to add this. I'm going to add a new folder here. All right. For my person console, I'm going to add a new folder. And I'm going to call it Java because I want to show you how this same thing would be written in Java. Why? Because it's almost remarkably similar to what we're doing right now. All right. It's not exactly the same, but it's going to be very, very, very close. And the reason I'm showing you this, we're not going to run the program, but I want to show you how similar the two languages are. And then after we get done with this, I'm going to attempt to go back and rewrite this program that you're seeing in here right now, this person program. I'm going to attempt to go back in there and rewrite it as a GUI app. All right, we'll see where we are time-wise. I'm going till 12. I figure I'm not stopping. I've got my water next to me. I've been going for 2.5 hours, and I figure 4 hours of this is enough. All right. So if I look on here right now, it says that I've right now been going for almost 2 hours and 25 minutes. all right, other than my periodic goofy times when the internet is going down, which bugs the bejeepers out of me. So I'm going to go over here into Java, and I'm going to click Add, and I'm going to click New Item, and I'm going to put in here I'm going to call it person.java. All right, and I'm going to attempt to add that, and it's just going to give me a blank file. Okay. All right, and I'm going to start typing. So I'm going to, oh, hello, not there. I want to bring that file up. There we go. All right. This one I did not put into a Java editor, so I don't think there's any mistakes in here. All right, but I suppose it's possible that there are. Let me change this because it's the wrong type. First thing to notice as you come in here, just like before, these are my instance variables. So they're set up very similarly to what we just saw. Now, just so you know, I didn't mention it before. I wish I would have, but I forgot to. So in here, when we did this, you don't have to start these with an underscore. It's kind of an unwritten tradition that you start instance variables with an underscore. I don't know who started it, but somebody did. Okay. All right, so here's my instance variables. Now, guess what? Getters. Usually in here, these are a lowercase, at least that's the way I've always done it. Just like we've done previously. So get first name, then this will be get last name, and get eye color and hair color. Notice that the Visual Studio is actually seeing some of these the words, and it's doing the coloring, but it's not recognizing everything, and that's why I'm not getting errors when I put the same thing in here and make the copies like I got before and before. But first name, last name, eye color, hair color, height, weight, hair color. This was gender, and this was a Boolean, and this was is married. Now there's tools that you can use with the Java editors that will basically create this whole thing for us without me having to type it in. If there are similar tools for Visual Studio, I don't know what they are. I'm not saying there aren't any. I just have not probably done a good enough job of checking out to see if there was. So now I'm going to put in my setters. So I had all my getters. So let me first change all these to void. Oops, not there. Because getters in either language don't return anything. These will all have a value passed in. And it's kind of a tradition in Java that you give it the same name. So that'll be first name, and it'll have to be the type, of course. So string first name. This will be string last name. String eye color. String hair color. Int height. Int weight. String gender. And Boolean is married. Now, it's typically in Java, you call what you're passing in the same name as the variable up here. You don't have to do that. But when you do that, you've got to do this. This dot first name equal first name. And I'm just going to do some copying and then I'll change it. Oh, wait a minute. These are my getters. I moved too far. So that one's correct. So these are my setters. All right, what's left in here? There are public. It's not returning anything. Eat, and we passed in just like we did before. All right, we passed in a string, which was food. And all we said in here, we don't use console dot, we use system dot out dot println. I think it's println, but I don't remember now. Let's see. No, it's all lowercase. In fact, so is this system.out.println. It will be the name of the person. So we will again come in just like before and do this where we say, put in a default constructor. And we will again say public person, boom, 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 like that. All right. And let's see, what did we put in here when we did it before? I think we can actually copy this. But I have to do this. There. Let me copy this down. And we'll put in drink. And we will put in, we get sleep. So this will be drink. So string, again, this was liquid. And this was sleep. And this was int num hours. All right. And that'll be is drinking. And this will be string, yeah, like it says there's string liquid, so it'll be drinking liquid. And this will be again, get first name plus last name is sleeping for num hours. All right. The reason I did this was not to waste my time, was not to waste your time. All right. Could there be errors in here? There probably are, but I wanted to show you just how similar these two languages are. To do this now, I'm going to take this that I just did, and I'm copying it to the clipboard. We do a file save all, so in case I screw something up. Let's go back to our person class that we had here. This is our C#. All right, and I'm going to come back into here, paste that in, make it smaller, and we cut that down and put it over the side here. All right. So when you look here, notice public class person, then our instance variables, they're private string. Here in the string class in Java is capitalized, and you don't put the underscores, but other than that, they pretty much look the same. The default constructor basically looks the same. Then we've got our getters. Move those getters up to the top, and I'll move this up. And what you should notice when you start looking at it is they're pretty much mirror images of one another. Again, we don't have the underscore as we, in Java like we do in C#, but those are our getters. Then when we jump out to our setters, again, they look similar. All right. And in here, usually what you actually call it in here, and I didn't do it like this, but usually since this is first name, you typically call this first name, all right, which means I'll have to change this, of course. Value is fine, all right, but actually value's got a separate meaning in here, so. So let's again keep doing this. There's a reason that I'm taking this time to do this with you. We used to, in the fourth semester, we used to teach Java. We don't anymore. Okay. But there are still students who are actually getting employed as Java programmers. And part of the reason for that is the fact that Java has so many similarities to C#. All right, so I changed a little. Notice I can use the same name, but since I don't have the underscore on what I'm passing in, I don't need this do in Java. So let me see. I want to move. Come on. All right, so those are our mutators. And if I bring that up, here's our mutators in Java. And you'll notice exactly how similar they are to one another. All right, as you start taking a look, there's not a lot of differences in these languages. Finally, when I go down to the bottom and I bring in the extra methods that we had here, so those are down here, class method, you want to call, okay? Again, other than I'm using system.out.println instead of WriteLine, they're virtually identical to one another. And again, the word string in JavaScript is uppercase. There actually is an uppercase string in C# as well. I just used the lowercase one. All right. So again, that was meant to show you how similar the two are to one another. Okay. So let me take this. I don't need this one anymore. So I'm going to remove that file. So you now have in your Java folder a person.java. All right. I'm going to create a new file in here, a new item. Again, I'm just going to call this person driver.java. Again, it's giving me another blank line, and this is the equivalent of my main. In fact, I'm going to, whoops, I don't know why it keeps doing that. That's on me. So I'm going to come in here and I'm going to key in this one. So again, public class main. All right. And I'm not going to explain what all this stuff in here is. It's not worth it because it's not a Java class. But I'm going to do just like we did before. So I'm going to say person1 equals new person, like that. And then I'm going to say, see if I can steal a bunch of stuff from what we had before in the other file. From right here. Okay, so let's see, got that. Okay, I'm going to grab everything that we have here. I don't need a read line. That doesn't make sense in a Java program. But I'm going to grab everything we had there and I'm going to copy it in. All right. Now, all these, again, would be commented back out again. Okay. So in other words, all these write lines that are here, there's probably a fast way to change these, but I'm going to manually do it. This will now become system.out.println. Okay, so I'm going to change all these write lines to system.out.println, not LIN. Okay, so we've got all these. Again, we're calling person1 dot get whatever, same way we did it before. I think that we said that in those, the gets were lowercase. So of course I have to change all these. I haven't taught Java for like 2 or 3 years. So sorry if you try doing this and you actually try putting it in and you get errors. I'm doing the best I can here, so. Okay. And then we do our calls to our setters. Person1 dot set everything. And again, I think these were lowercase, one that we just did. So you'll notice it's making these, they were blue because it's grabbing that and it thinks that it's still C sharp. As soon as I put in a lowercase, it doesn't recognize it. So all that highlighting is going away, the blueness or whatever you want to call it. All right, so this again will have to be system, all these will have to be system.out.print lines. Just grab one of them here. And yeah, that would be it. So I didn't try to waste your time there, but I wanted again to show you just how similar the two languages were /are to one another. All right, so let's see. Tell you what, this going for 2 hours and 47 minutes is a little wears on you. There's the Java, and I'm going to close that. There is the other Java. No, it's not. Somewhere in here is the other Java, and I'm going to close that. There it is. So I'm going to close that as well. All right. So here's the one that we've been working on so far. Okay. We've got 8 pieces of data. You know that it works, or you should know that it works. I'm going to close this Java folder now. And I want to make sure that I'm running my OOP person console. Already should be set correctly here, but I'm going to set my start project to this anyway. All right, so if I go back and rerun this, in fact, let's do this. Let's uncomment these. Okay, so let me stop that. Let me uncomment these. So it'll do that. And I'm going to put it, whoops, I want to uncomment them, not comment them. All right. So after this, I'm going to add here just a right line. I'm going to put in a couple \n's like that. All right. And then we're doing the setters, and then we're doing those again. Okay. And I'm also going to do that here. What I'm just doing here is I'm just kind of splitting up everything that I'm doing so you can see everything. Let's see if it worked or not. So there's printing them out with all the getters, and that's the default values. Then we added our getters after our setters, and I can put a heading here too that said call the additional methods. Okay. Because I didn't need that many blank lines, but it's fine. So let me grab this. And we'll put one more right line in here. And I'm going to say calling the non-setter, non-getter methods of the person class. Let's see if all that works. So again, there's our defaults. There's after doing the setters and getters, and there's our non-setter getter methods. So you can see all that stuff has now been done. All right. All right. What I want to do next then is I want to rewrite this. It's going to look pretty simplistic, And I'm going to keep this open because I may be able to use a lot of this stuff, but I'm going to make a new project. Normally, I would write this so that I could share this stuff. I'm trying to think of if I can do that or not, but okay. We'll get to talking more about sharing, but not right now. So I'm going to come in here and I'm going to create a new project. So add a new project. It will be a Windows Forms project. The other one we called OOP Person Console. So this will be OOP Person GUI. Okay. Okay, I'm going to widen this out a little bit or make it higher. I guess it doesn't even have to probably be that wide, but that's okay. All right. So I'm going to come in and change the name. So this will be FRM Person GUI. And yes, we want to change it everywhere. Let's see, what else do we want to do here? We want that to be our startup project. So let's just do that right away. Let's go in and change. When we did this before, did we put in for the console? Oh, that was console. So for again, let's change the background color. I want this to say something relatively light. Let's go green is fine. We'll change we'll immediately change the startup mode to center screen. And we'll change this. I'm going to say AWD1100 object oriented programming OOP GUI person app. I don't know, something like that is fine. All right, so what do I want to do in here? Okay, again, let's do kind of what we typically do when we start, and that is let's add 3 buttons. Okay, too bad. And I'm just going to kind of do it a little bit differently than I normally do. I'm going to immediately set the size on these. Usually I'll wait till the end, but I'm just going to do them a control at a time. So that's those. This is going, oops. This is going to be, I'm going to call this one what it is. So this will be BTN instantiate. And the text on the button will be instantiate. All right, this one will be clear. So again, it'll be BTN clear. And this will be exit, and it'll be BTN exit. All right. I'm going to need 8 labels and 8 text boxes. So let's grab the first label here, and we will change the background color. I'm also, I can keep it black. I think it'll work fine. Auto size to false. 5, 6, 7, 8. Looks like I've got one too many. So I don't need that. So delete. Come on, try to delete that. Delete. There we go. All right, I think that's okay. We're going to, let's just do these right away as well. So I will change the size on these as well to 24, bold, and Arial. Okay. Let's take each one of these. Hopefully it'll let me do this. There we go. All right, and let's add our text boxes. I think I'm going to make these wider. They don't necessarily have to be, but I am anyway. Make it look somewhat symmetrical. Good morning. What we're doing, just so you know, is so far what I've done in here is I have created a fairly simple object-oriented program using C#, and I did it as a console app. I am now redoing it, and I'm going to redo it as a GUI app. All right. In addition, I created just a real simple program, and I went through the fact, and I'll show it to you on here as well. All right. So let me just grab these and make these bigger. All right. And let me change the text align to center. And let me change the text align on these to center as well. Now, one of the things that I mentioned, all right, one of the things that I mentioned in here earlier, and I just want everybody to know, and that is you have been using object-oriented programming all semester, even though you probably don't realize it. All right. And what I mean is, again, if I open up the designer file, you've seen this file a little bit before. So the only thing I've named right now have been my buttons. Everything else has got their default names. And you might say, yeah, that's fine. But what you don't know probably is if I come in here and click this plus sign and I go down to here, notice what I've done. I've created or instantiated 3 buttons, 8 labels, and 8 text boxes. So these right here, remember that initialized component, that is what is called at the beginning. So that is instantiating or creating each one of these. And as I go in here, and you'll see it in a moment, but as I go back in here, I'm going to do all this right now for you. I'm going to change the name on each one of these. So this will become LBL first name, and it'll have the text in there of first name. All right, and this will become TXT first name. This will take me about 5 minutes. Next, we're going to have TXT last name. The label again will be LBL last name. And the text on the label will be last name. All right. And geez Louise, Jeffrey. here. Okay, then we had eye color and hair color. So this will be LBL eye color. This will be TXT eye color. This will be hair color. As will this. All right, and I didn't put a colon in there. All righty. This will be height. This will be weight. This will be gender. And finally, this will be, we'll call it marital status. Okay. And again, LBL marital status. And this will be TXT marital status. All right. Now that's everything. I don't think I've missed anything. I'm going to go back and double check. It doesn't look like it looks like I have renamed, oh, there's a text box 4 in there. So I did not hit that one. That is this one. So that should be TXT hair color. Let's check it one more time. Now I think everything has been renamed. Okay, as always then, all right, I'm going to come in here and I'm going to set my accept button to BTN instantiate. I'm going to set my cancel button to BTN clear. I think I set the start position already. I did, to center screen. These are all, none of these are going to be read only. So I'm going to set my tab order to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. So again, if I go over to my, I don't need this. I go over to here and I run it. Okay, it is centered. There's everything. I haven't put any code in yet, and that's okay. All right. All right. So again, if I come back to here, now you'll notice all the names have been changed. Okay. BTN, LBL, etc. So the point is that when you initialize components, what the system is looking for, because C# is an object-oriented programming language. So C# is looking right there, and it is looking to see if, at least possibly, there are any controls that it has to come in and instantiate. All right. And in here, after we do this, so this is instantiating or creating those controls. All right. If I keep going down, then we're setting what are called the attributes, the data, so to speak, the attributes for each control. So we set the font, the location, the name, the size, the tab index, the text, and the use visual style back color to true for all of these. And we did those for all three of the buttons. Then we did it for all of the labels. First name, last name, etc. Then we did it for all of the text boxes. I believe it puts them in here in the order in which you put them on the screen. All right. Now, there's nothing wrong with looking at this file, this designer file, like I'm doing right now. That said, I would never, as in never, 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 ever recommend that if you're going to do that, again, I would never recommend that you make any changes to this file. The only time you may have to is if you remove something and you don't remove it the way that I showed it to you in class, where you go over to that lightning bolt and you remove the stuff from there. All right. Even the form in here, notice what it's doing. All right. It's set the accept button. It's set the cancel button. It's got the dimensions or the size. It's got the scaling. All right. Then notice it's adding all those controls to the form. All right. So all that stuff is happening. This stuff that's in here has happened. It has happened in every program that we've done in here, every GUI program that we've done all semester long. All right. We didn't talk about it beforehand because, not to be funny or anything else, there really was no reason to do it. All right. There really and truly was no reason to do this. All right. Now, I'm going to come back to here. Okay. Well, make that to here. There we go. And when we instantiate, what we're doing basically is we're coming in and we are creating a brand new item, for lack of better words. All right. I'm saying this again. So what we're basically doing in here is we're creating a brand new, what we want to do when we click instantiate, we want to create a new person. All right. Now, what I could have done, I didn't do this, but what I could have done would have been just to have a button in here that said instantiate. Then instead of having all this stuff, we could have hard coded it right into the program and then put it in like I could have had the button maybe up here someplace, then had a real big label and hard coded all of that stuff in there, and then just shown exactly what we wanted to show as far as what's in the label. So, I mean, like I said, that's another way that it could be done. All right. And does that make a lot of sense? To me, it doesn't. All right. But we could do that, is what I'm telling you. We could do that. All right. Now what we're going to do when we did this program previously, when we did this program as a GUI program, all right, when we did this as a GUI, that's it right there, but I want to get the other file. So let me go over to here. And in the GUI, in the console program that we did, we created a new class. Class is something new. I went over all these definitions for the first hour today, but we created a person class. And we said that each time we create a person, they're going to have the variables that you see right here. All right, so each person is going to have every one of these variables that you see right there. Don't worry about what they are. It really and truly is not that important. All right. Now, it is convention, again, that when you do this, that you come in here and you start the variables with an underscore. If you don't do it, it doesn't hurt anything. There are no OOP, object-oriented programming, OOP, OOP. There are no OOP police, but it's just kind of the way people typically do things. All right. So normally what we do is we would have one class, this class that I created up here. We would use that both for our GUI app and also for our console app. I'm not doing it that way, and there's reasons for it I don't want to get into right now. But going back then to my GUI app right here, right there. All right, I'm going to right mouse click on here, and I'm going to choose add, and I'm going to go down right near the bottom, and I'm going to choose class. I'm now in my GUI one, and I'm going to make another person.cs. And that's going to create a brand new file. All right. You'll notice if you look that the namespace says OOP person GUI, which is the name of the project. If I go back to my other file, we close a couple of these because it'll get confusing. There, OOP person GUI. All right. So what I want to do in here, and we're going to go over all of this. I have not talked 1 second, not 1 second about chapter 12 today. All right, we're going to do that on Monday. But I wanted to show you some examples. Take my time showing you these examples. And I also said I'm going to go until noon. 4 hours for the first day on this stuff is enough. I started at 8. I have not taken a break. All right, I've been going now for 3 hours and 12 minutes. The only time I've had to take a mini break is when my internet connection went down, which has happened, unfortunately, quite a few times. All right. So I'm going to come in here and I'm going to change this. We're going to essentially always make our classes public. And in chapter 12, we'll talk about the difference between public and private and internal and protected, etc. We'll talk about all of that stuff. So I'm going to come in here and I'm going to create what are called my instance variables. So every time I create a person, all right, so I'm going to have private string underscore first name. So every person will have their own unique first name, their own unique last name. All right. Their own unique eye color, their own unique hair color, their own unique height, their own unique weight. See, the intelligence is trying to help, and sometimes it's getting it right, sometimes it's not. All right. So those are my 8 instance variables. They are gray right now because there is nothing in my program. There is nothing in my program that is referencing these variables. So we're going to change that right now. Now, I mentioned before that these things are also referred to, this is the program data, and the data is also referred to as, they're also called attributes. All right. And I also said, or properties. That's not really true. What we're going to do right now is I'm going to set these things as properties. All right. When I did the other example, when I did the console example, I purposely wrote it like, here it is. So you can see it started out the same, but I purposely did it so it was like a Java program. I used what are called getters, and then I used what are called setters. All right, so that's what I did. You didn't have to do it that way, but I did it because I wanted to show the similarities and the differences between Java and C#. All right, but now I'm going to use what are actually called properties. All right, so I'm going to say here, set and get data using properties. Now, what we're going to have to do in this class, and it's unfortunate, but it's kind of, for lack of better words, it's sort of a necessary evil. And that is, there are 3 or 4 different ways of doing this. I'm going to show you all of them, not right now. Why? Because in our book, they demonstrate all of the different ways of doing this. So I'm going to do it like that. All right. So I'm going to come in here and I'm going to kind of do this, what, for lack of better words, what we'll call the long way. So I'm going to say public string first name. All right. And you can see that the IntelliSense is already clicking in here. All right. What do I mean? Well, if I hit enter, and it's unfortunate that there's probably a way to auto format that, and I don't know what it is. But this is how we set the first name. So if we ever try to reference the first name where we want its value, it's going to return that value that we did up here. And you notice it's not gray anymore. If we attempt to set the value for our first name, then it's going to call this. All right, so let me do some copying here, and I'll make change it around as we get going. So let me do this. All right, I'm going to get all sorts of errors. Don't worry about it. We're going to fix all of them right now. So this will be last name. And you'll notice as soon as I do this, all the errors will be going away. All right, I just did it so you didn't have to watch me type. This will be eye color. All right, so that's all of those. There's 4 more. Now this is going to change because these will be the height and the weight, and their numbers. So, oh, hello. All right. It may, there we go. All right. Let me just copy the whole inside of this and change all the H's to W's. W, W, that is weight. And of course, that is an int. And weight, return weight, weight equal value. No, it doesn't like here. Public and weight. Weight does not exist in this context. We forgot to put weight in there, that's why. E4, 5, 6, 7, 8, 9. Oh, because we put width in instead of weight. That's why I got the Okay, so there's weight. Somehow that became a W. All right. This is gender. And so is this. I missed one evidently. And so is this. Let me copy this down one more time. And this is going to be a bool. And it's going to be called is married. Now, probably one of the hardest things to do and get used to as you're doing this stuff is, wow, this is totally frigging different than the way we did it before. And you know what? Yes, it is. We are creating an external file here that we want our main program file to be able to utilize. So what we're saying here, what the word instance means is every time that we want to come in here and create a new person, which is what we're going to want to do, every time we create a new person, each new person or each instance of a new person will have his or her own first name, last name, eye color, hair color, height, weight, gender, and marital status. Just as you can imagine, if we went and brought in a group of 10 people, for example, all right, they would all have different first names, last names, eye colors, hair colors, heights, weights, genders, and marital statuses. All right. Then when we want to attempt to either when you set something, it means that that variable name, when you set it, is on the left-hand side of an equal sign. You are changing it. Setters are also known as mutators, meaning that you're going to be changing a value. Getters are also known as accessors. So if you can imagine, I've used this example before, I don't think in your class, but let's say we walk into class the first day. I know that this is online, but let's just pretend for a minute that we're in a classroom. So you walk in the first day of class and you're 15 minutes early and you say, good morning. I say, good morning. What's your name? And you say, James. Okay. And I look at the attendance sheet and I notice I've got three people named James. So I decide that, you know what, from now on, the first James, you're going to be Jim. The second James is going to be Jimmy. And the last one is going to be James. I'm mutating. I am changing what I'm going to call you in essence. So when you change a value, that's a set. If you come in the first day and I say, what's your name? And you say, Oliver, and you're the only Oliver in the class, I say, good morning, Oliver. It's nice to meet you. That's an accessor. So if I ask you a question and you give me an answer, you are using get. Right? If I tell you something more or less as a command, you're using set. So this is how we work with these things. And our first name has got its own getter and setter, our last name, etc. And if people have asked me, then why do you have this goofy thing in here? And why is this a capital F? Why doesn't it look like this? It's the convention that the language uses. I'm not sure if that's a great explanation, but for now, at least, it's the best one I can give you. All right. So what we would like to be able to do, all right, is to make some changes in here. Now, I want to show you this. I'm purposely showing it to you like this. This is the long, fangled way of doing it. All right. The harder way, because I want to show you what's going on in here. All right. What we will get to in not very long as instead of writing it like this, I'm going to comment this out. We're going to write these like this. So our getter will look like this. You can see the difference. It's a lot less typing. All right. So what I'm going to do is I'm going to comment these two out and put them at the bottom. So that's what we'll be getting to. I'm not trying to confuse you here. Not at all. In fact, it's the opposite. The problem is if you get a group of programmers in, they will all do their own thing in different ways. All right. Some people like the way I'm showing here that is not commented because they think it's a lot more straightforward as far as what we're doing. Other people don't like that. All right. And it's pretty much for the same reason. It's because one way makes sense to them or another way doesn't make sense to them. All right. And again, that's not what I'm giving you here is not the greatest explanation, but I'm trying to keep this literally as simplistic as we possibly can right now. All right. So, all right, we've got all this stuff. All right, good. Now I want to jump back into where are we? Come on, that file. And this isn't going to change. All right, as far as, let me go back, close this. Our clear isn't going to change, and our exit isn't going to change. So for our clear, we've got that old clear all. And again, you don't have to call it that, of course. All right, but we still have txt first name dot text equal nothing, txt last name dot text. I'm not going to worry about straightening these things up now. Txt eye color dot text, txt hair color dot text, txt height, txt weight, txt gender. And, I've given this kind of lecture before, and sometimes somebody will say to me, why didn't you make those radio buttons? Because I didn't want to put in a ton of different controls here. All right. And the reason that I didn't want to do that, do we call it marital status? I don't remember. Let's look. Yep. I'm trying to concentrate on one thing at a time. When you did the last program, we were concentrating, when you did your test yesterday, we were concentrating on what? Well, hopefully you agree with this. We were concentrating on adding those new controls and being able to work with them. Now we're not working with that. All right. We're working with using classes and objects, etc. All right. And give me a second. I'm going to pull this out of an old program. So let's see. And I haven't. right. There we go. All right, so like I said, this part of the program is going to work the same way that it always has. All right. Okay. But what's going to be new is if you haven't guessed it already, is the instantiate. Because what we want to do is every time we come in here, so every time that we come in here, where are we? And we put in a value for each one of these, and we click instantiate, what we'll want to have happen, if this works correctly, is we'll want to have a message box come up, and it'll say first name Jeff, last name Scott, eye color blue, hair color brown, etc. All right. And then I can clear and I can bring in another person. All right. So we're creating person objects. The reason I'm using the word instantiate here is what we created over here. This is a person class. Each time you create an object or a member of that person class, it's called instantiating. When you instantiate, what you're doing is you are creating an object based off of a class. That's exactly what we want to do in here. I'm saying this again. That's exactly what we want to be able to do in here. All right. So when I've got some notes on the other computer that I'm using, and I'm just trying, I've gotten way behind on that one, unfortunately. So I'm trying to catch up on here. Give me just a second, if you would, please. And hear how far behind I've gotten. All right. Well, for some reason, now it's not showing anything on my screen, but that's okay. All right. So when I come in here and I click instantiate, I'm going to call create new person object. All right. Which of course doesn't exist. All right. So private void create new person object. Now, one more thing. Normally, I'd come in here and I'd use try catches. So if there was nothing in here, I would just use a try catch to make sure there was a value in for each one of these. I'd have a height with a constant and a weight with a constant, etc. Hopefully that makes sense to everybody. All right. But just because I'm trying to get this done by noon, so I've got something I can show you. All right. I'm bypassing a lot of that stuff for today. All right. I will do a little bit, but almost nothing. So here I'm going to say add first name. In fact, let's not, yeah, we'll do it like that. That's fine. In fact, let's do the way we have been doing it. Our bool, keep going, equal, add first name. All right, we of course don't have that written, so let's write it right down below here. All right, so I will do private bool, add first name. And I'm just going to say, I'm going to keep this, like I said, simple. I'm going to say if txt first name dot text dot trim, if that's equal to nothing, all right, we'll do one of our old show messages, and I'm going to put that down on the bottom here. All right, I'm going to make that an error. So if there's nothing in the first name, all right, we're going to do a show message. It's pretty obvious. Very, very similar to the way we've been doing things in the past. Basically, it is the same. So I'm going to say here, if keep going, well, what do we know? Then we know there was something in that first name text box. So I'm going to say keep going equal add last name. All right, again, I'll get an error because that hasn't been written. Else return. So right now I'm going to comment this line out. But if I do come in here and run this and I don't put any, oops, what's the error? So if I do run this and I don't put in a first name, I get my error. Blank first name cannot be blank. Good. And that's all I'm doing. And right now, if I put in something, boom, it keeps going. That's what I want to do. All right. So we've got 8 of these. So to try to make it fast, like I said, it's my goal to be done here in about 23 minutes. I don't think that's going to happen, but we're going to try it anyway. So I'm going to put this in here. And now I'm going to add this and I'm going to make it last name. All right. And just so I've got them in here, I'm going to bring another one in and I'm going to call this eye color. All right. So that's that one. Last. Good. Copy this. Whoops. We copy this down. All right. Those are done. So I got 4 of them done. All right, so I'm not checking necessarily for something valid in these fields. I'm just checking for the presence or absence. So if I come in here now, you'll notice that if any of them are blank, I reset the cursor. Last, what did it say last there? Yep, last. Eye color, hair color. Now, when you start to think about this, all right, and I'm going to do the other four right now, but when you start to think about this, what I want you to please start to get inside of your heads is this, and that is, wow, let's see. For eye color, how many different eye colors are there? I mean, to me, there's black or brown, blue, green. I don't know what else there is. I could probably check, but I could put those into an array and then check to make sure those were all done. Hair color is harder because you've seen enough people in your life, you know that some people have really, really, really weird hair colors. All right. So for height and weight, I'm not going to do any validity checking. I would normally do that. Same thing with gender. All right. I would normally do that, but I want, like I said, I want to go and get this done. And it's not that I'm trying to see how fast I can do this, but I want us to be able to use this one. So when we back in on Monday, we can really start to pick this apart and take a look at it. All right. There's a very good chance, even on Monday, we won't go into the book. I want to say that again. There's a really good chance on Monday we still won't go into the book. I want to deluge you with examples, and then we'll go into the book. All right, then we'll worry about that. All right, so we've got next are the height and the weight. Not signed in there. I don't know why it is. And I don't have add height written yet, so that'll give me an error. That's why I'm getting errors now in the program, so I'll fix that momentarily. All right, and well, I might as well just put in the weight one too. Oops, and I'm going to write both those right now. All right, so for now, I'll just grab one of these and I'll make an add height and an add weight. All right, so this will be add height. And again, normally I would come in, use the try catch, or use the data validation, etc. I'm not doing that now. All right, so I can come in here and check to see if the height is empty. And if it is, I can say the height cannot be blank. All right, and reset it just like that. Let's see. All right. Now there is going to be a problem. Okay. So if it's blank, what I want to do here is, let's see. So I've got add height. That's good. I'm going to come in here and add a right here. I'm going to say int height. I'll show you why in about a minute. Int weight. These are the only ones that aren't strings or aren't Booleans. All right. So for this one, if it worked, all right, then I'm going to say height equal int32 dot parse txt height dot text. Normally, again, I would use the try parse and I'd come in and try to fiddle with it and get it to work, but I'm not doing that now. All right. So there is the add height. I'm going to just come in here and immediately underneath that, put an add weight in. All right, and change all these. All right, and now I've got two left, and that is gender and marital status. All right, so let me put those in. So this will be add gender. Okay, and then finally we'll add the one for marital status. All right, let me call those. So, all right. So if I've gotten down to this point now, I've made all my checks. So instantiate the person object. So I'm going to do this. I'm going to say person equals new person. Now, there's something remarkable that you may or may not have realized when you look here. I am referencing person, which is not in this file. It's in the other file. All right. So I want to see, this isn't the greatest way of doing it, but I want to see if this is going to work. Oh, I was hoping that would. So let's see. First name. Well, let's go back and look and see if it does or doesn't. There's the first name, equal value. What doesn't it like? I think I know what it is. Let's see. Okay. So we should now be able to. All right. We'll have last name. We'll have eye color and hair color. We have height and weight. That'll be height. Then I don't have to worry about formatting it. And Okay. Oops, that was good. That's fine. Person of marital status equal. All right, so let's look at that. I think I call that is married in here instead of marital status, but we'll look. Let's change that to marital status and that as well. I'm getting errors. I'm going to fix the error. It's up at the top where I've defined it. So that's up here. So I want to change that is married to marital status. Errors go away. Come on. There we go. All right. All right. That's giving me an error here because I'm trying to put a string into a Boolean. I'm just going to say true, just so it compiles. All right. So we've got all that. Let's do we'll just do a message box dot show. Here is your person. Name. Now I'm going to try this and see if we can get it to work. Person dot get first name. It doesn't like that. Okay, great. So that'll be the name. Then after the name on the next line, we're going to say eye color. And finally, we'll have gender. All right. I have no errors. That's great. Let's see if it works. So here is your stuff. Wow. I'm honestly, I'm amazed that it all worked. Okay. Now, a few things I'm going to have to pretty up in here. It's no biggie whatsoever. All right. I'll put inches after this, pounds after this, etc. I'll make sure that the name, this goes on a new line. But what we've been able to do in here is we have three examples that we created today. In the first example, there was absolutely nothing object oriented in it, or was there? The first example was unbelievably simplistic. It was this. It had a name with a text box for name and a greeting. That was it. That's literally all it had. All right. I also showed on this one, when we ran it, we changed some of this stuff at runtime. So I made the button black with white text. But the reason I brought this one up was to show you that even in this simple example that's right here, all right, when we go in here and we look at our designer file, again, you are instantiating objects, you are setting attributes for each one of the objects and for the form itself. All right. That's what I wanted to show in that particular example. All right. From there, we went in and we created an example in here. All right. And just to show it to you. All right. So we created a person project. So that was the first one, that real simplistic one. Then we created a person one that was console. All right. And let me set the startup project. So when we set that one up, what you can see in here is I showed you the default options using just getters. Then we went in and used the set function. All right. And then I didn't bring these into the last one, but it's no big thing. We could bring those in too. And I added the non-getter and setter. Then finally, I went back and rewrote this one more time in the one that you just saw, that being this OOP person GUI. Now, after 4 hours, this goes away, and it's been going 3 hours and 59 minutes. I am finished. If you have any questions, email me. This stuff will be out there by around 12:30. That's what I had for today. This is what I wanted to get through. We're going to pick it up right here on Monday. Please have a nice weekend. I'll talk to you then. Thanks.